Alright, in this video we'll be talking about what is a parallel circuit. Now again, although it might seem like a pretty simple concept, like I said in my video about what is a series circuit, I'm pretty sure most of you have never actually been told by definition what is a parallel circuit. And so based on that, pretty much every time you see a parallel circuit, either in a practice question or an exam, you've pretty much just gone on vibes and intuition whether or not components are in parallel or in series. Now, although you might have gotten it right most of the time because in NCEA they make it pretty obvious, so you can get away with not really knowing the definition, I would still like to teach you the proper method and the proper definition so you can be 100% sure whether components are in series or in parallel. So in this video we'll be talking about parallel components, okay? So let's draw out a circuit right over here and we would have a component right over here, okay? And another component right over here. Now, right off the bat, you've probably looked at that and gone, that is a parallel circuit, and with that, you would be correct. It is a parallel circuit. However, what I bet you're a little bit less unsure of is why it's a parallel circuit. And that's why I say most people just go on vibes based on whether components are in parallel or series, okay? So that's what I'm here to teach you, okay? Components in a circuit are said to be in parallel if and only if they're connected together by both of their ends, okay? And so what we can say is that two components are in parallel if they share both of their nodes, okay? Now, what is a node? A node within an electrical circuit is a point at which two or more components are connected together either directly or via ideal wires, okay? And so you can see here that these two components aren't connected together directly. However, we can see that they are connected together via these two ideal wires. And so we can say that they both share the same node, okay? And same thing on this side. Although they're not directly connected, they both share the same ideal wire, and therefore they both share a node. And by our definition, two components are said to be in parallel if they share both nodes. And as you can see, these two components share both of their nodes, like so. And so these two components are in parallel, and therefore as these are the only components within the circuit, this circuit is said to be a parallel circuit. Now, and to say that calling something a parallel circuit is most of the time an abuse of terminology, okay? I will show you what I mean by that. Let's say we have a circuit right here, okay? And we have two components like this, like so, and then we have one component down here. Most people would say this is a parallel circuit, and I would also say it's a parallel circuit because it's common language to denote this as a parallel circuit. However, as we can see here, these two components are in series, okay? And these two components are in parallel with this one component, okay? And so therefore we have both components in parallel, but also we have some components that are in series. And so if there are some components in series and some components in parallel within a circuit, how can we call it a parallel or series circuit, okay? And so realistically, we should stop calling circuits either in series or in parallel. We should only talk about the components themselves. Are the components in parallel or are the components in series, okay? Now, as for voltage, we should know that in a parallel circuit, the voltage is the same across each branch. However, why is it the same, okay? Well, the reason why it's the same is because let's call this a 5-volt source, okay? That means that the voltage across the source is 5 volts, okay? Meaning that each coulomb of charge from this side of the circuit gains 5 joules of energy when it goes through the power supply and ends up on this side of the circuit, okay? Now, as we can see, the charge entering this power supply shares a node with this component and this component, right? It shares this node right here. Same thing over here. The charge leaving this power supply shares a node with this component and this component, okay? So if we said that the voltage across this power supply is 5 volts, well, that means because this power supply shares nodes with this component and this component, that also means that the voltage across this component must be 5 volts, and the voltage across this component must also be 5 volts. Now, as for current, well, like I said in my series circuits video, things are considered in series when charge only has one pathway to follow, okay? However, we can see in parallel that there are multiple paths for the charge to flow through. So it flows through here, and then it has a choice to split over here or go down over here, okay? And so this is the reason why the current in each branch is different, because the current coming from the power supply splits off at each branch, okay? And how much current goes through each branch is based on the resistance value of each branch, right? If this branch has a total resistance of 10 ohms and this has 5 ohms, right? More current is going to flow through here because it's easier to flow, right? There's less resistance for the charge to flow through. All right, so this next section assumes that you have watched the what is a series circuit video. okay? So if you haven't watched that, then you can go watch that and then come back to this part later. But what I want to do is show you some circuits and you can answer whether or not the components are in series or in parallel, all right? So our first one is if we have a power supply right here and then we have a component over here like so. Is this circuit in series or in parallel? You can pause the video and try to answer that. Now, I assume most people would have said that this is in series. And with that, you are technically not wrong, but you're not fully correct. If you said that this circuit is in parallel, you are also not wrong, but you're also not fully correct. This circuit is both series and parallel. All right, both series and parallel. So now that you know the answer, can you answer why it's both series and parallel? You can pause the video and I'll give you some time to answer that. So the reason why it's in series is because there is only one pathway for charge to flow, okay? The charge doesn't have any choice and it has to flow in this direction right here, okay? So therefore, it's in series. However, because these two components share a node, okay? Remember, nodes in a circuit is a point at which two or more components are connected directly or via an ideal wire. And as you can see, this power supply and this component is connected on both sides via an ideal wire, okay? And so both ends share a node and therefore they're in parallel. And so the circuit is both in series and in parallel. Let's say we have a circuit like so, where we have a source here, a resistor here, okay? Comes up, we have a node over here, resistor down here, okay, this is connected like so, and then we have another branch where we have another power supply, okay, and another resistor, like so. Are these components in series or in parallel, or neither, or both? In this case, the components in this circuit are neither in series nor in parallel, okay? It is not in series because there are multiple pathways for current to flow, okay? As you can see, we have multiple branches. However, the components are also not in parallel because none of the components share nodes. We can see that this component shares a node with this component, right? It's going to be this node. However, it does not share its other node with this component, and so therefore these two are not in parallel, okay? Let's see about this. Is this in parallel? Well, this shares a node with this component and this component. However, it does not share its other node with this component, and therefore it's not in parallel. And you can go along through each component, and what you'll find out is that a given component will share a node with one or more of the other components. However, the other node on the other side will not share a node with the same component, and therefore those two components will not be in parallel. And so therefore, the components in this circuit are neither in series or in parallel. And so the point of this was to show you that A, it is not always the case where we have just a parallel circuit and a series circuit, okay? It's more so about talking about the components, whether or not the components are in series or the components are in parallel, okay? And as we saw over here, a circuit can either be both in series or in parallel, okay? So it's not just clean cut one or the other. And over here, I showed you that series or in parallel are not the only two options, okay? Every circuit doesn't need to be in circuit or in parallel. It can be neither, okay? And that will be it for this video. See you.